record. All right. So today we are really taking, to use a swimming metaphor, we are diving into the pool of React. We're gonna really start learning about what makes React special. We're going to talk about, well, first we'll do a little review, and then we'll talk about React's virtual DOM, how it actually models the DOM in JavaScript versus the real DOM, and what that means in terms of the stuff React can do. We'll see what's called a useState hook, which is going to give us a lot of power and control over interactivity, and we will no longer have to modify the DOM directly, which will be great. We'll see a useEffect hook that is really for making HTTP requests, um, also known as side effects. And we'll talk a little bit about what that is. And we'll see some good patterns using our favorite API, the Pokemon API. And we'll see some conditional rendering. My goal is to get through this in the first part so that we can get some hands-on time with these assignments. And so hopefully we'll have 30 minutes to an hour of work time. And then in part two, we'll talk about React components and what a prop is. We'll see how map and filter get used with React, and we'll see some other patterns. And this will help give us patterns for making our React apps bigger. This is the page in today's curriculum that has most of what we're going to cover. I do strongly recommend reading through this at some point if you haven't. It's pretty well laid out and we have a lot of diagrams, so I think this is a really useful supplement. Do folks have any questions before we dive on in? All right, let's just start with a little review. And let me go ahead and give myself a bit more space over here. Think about like that. So I'm just going to navigate into my directory for part one of the lecture. And I need to create a new project with V and npm. And I'm going to use that dot. So it creates it in our current directory. And we're going to build a React project and it's going to have JavaScript. I'm going to run npm install. And that's going to install all the dependencies for our sort of boilerplate React project that we created for us. It's going to look at this package.json and install everything. And while it does that, it installs everything into the node modules directory that it's creating. And it creates that package lock JSON file. And now I can run this dev script over here to get my app up and running. And this will run the Vite dev server, which is a little dev server. And now over here, if I go to localhost 5173, and we'll pull up DevTools just to kind of have it here on the ready. We've got our app up and running. Now someone remind me, like if I was to sort of trace the flow from the browser to the V app, and in fact, let's go ahead and refresh this. There's all this stuff that happens, but if I go all the way up here, we see this response come back. What file is sort of our starting point in our React app that we see here being sent from the VTEV server to the browser in this very first request?
Your HTML index.
Yeah, exactly. So the first thing that happens is the browser requests index.html from the VTEV server. Then the browser reads through this HTML file line by line, right? And it's building this HTML document. Then what's special about line 11 here? What happens on line 11?
You run main.jsx.
Yep. The browser makes another HTTP GET request to the server to get the main JSX file. The server sends it back. And then, just like you were saying, the browser executes main.jsx. And that really sets us off to the races. And so let's go now, and we're just following the flow of execution for our application here to main.jsx. And there's a lot happening under the hood that Vite does for us in terms of bundling up these import statements so it all gets sent to the browser. But basically, in essence, by getting main.jsx, the browser is also grabbing everything else. And so we import React. We import the React DOM library that lets us interact with the browser's DOM. And then we import our app component. And can someone remind me what is this line 6 doing right here? This React DOM create root. What's like a two-sentence description of what that line does?
It grabs that root from the HTML file and displays whatever code that you're returning from the app.
Yeah, great description. I was just trying to hop back to index.html. We've got this div in there with an ID of root, and create root will get that element, and it tells React to render, which is the term for turning a React component into DOM elements. Remember, a component is a function that returns stuff to be rendered to the DOM. And it mounts is the term when you attach a component to a DOM element. Our component, and this is our sort of parent component for our whole React app, to the DOM. And inside here, we then see our application. Um, and so now our JavaScript is running in the browser, and the React.js library is running in the browser. And it knows that this is sort of the parent element when it's building out other elements to be rendered to the DOM for our application. And we can see here all our different stuff that is inside app.jsx. Now, this React strict mode stuff, right now, get rid of it. I'll talk more about what it does. Probably not now, but later. But this makes local development a little easier. And so now I've got my app JSX, and we have all sorts of fancy stuff happening here, right? Main JSX loads some CSS first from index.css, which we don't want. And if we go to app.jsx, we see app CSS also has more CSS, which we don't want. And now we can just start getting rid of more things that we don't want, right? I don't really care about these React logos. Today's lesson is going to be about useState and useEffect. So let's just put that there. And for the moment, let's just kind of get rid of all this, and we'll just put a little message here that just says, you know, Pokemon. And we're going to come back to state in just a minute. I'll leave it here as the import, and we'll get rid of this. Let's do a little bit of coding and then a little bit of talking, and then we'll dive into useEffect. So if I have, a Pokemon name, can someone remind me how can I display this Pokemon data in my React component? Not a trick question.
Put it in curly braces and put it in between an HTML element.
Yeah, exactly. Let's just do maybe an H3, and which will say Pokemon data. And the curly braces are escape character where we can add in the Pokemon information. And what if I want to capitalize Pikachu's name?
Do dot title.
Yeah, it's in JavaScript.
Uh,
It it might
Is it two,
be.
two upper?
Yeah.
Yeah, yeah.
Would two upper do everything to upper though?
yeah,
Oh,
two upper
what?
would do everything.
Or to title case.
Is it two title?
Nope.
There's no way in JavaScript to do title casing without slicing.
Oh, there's, but
Oh, I was muted. Yeah, you have to essentially,
Just slice the first.
it's a whole thing. Char at 0 plus slice 1 to length, and it's gross.
oh yeah. Okay. Then that may be more
So you'd probably do, yeah.
than it's worth, to be honest. I thought this would be easy, but yeah, we have to do like a big whole mess.
So a temporary solution. Why don't we capitalize it in the const up above, and then when we make the API call, if it's case sensitive, we can lowercase the entire
Right.
thing. That's what I would do.
Encode it in a language that doesn't have capital letters and it'll be fine.
Yeah. No, I think I think
Japanese.
I think we'll just skip it. My brain was in Python mode too. I
Yeah.
was thinking of this, you know. But this serves the intended purpose just of demonstrating that, we can execute JavaScript in here. So this is nice, right? I see that I've got JavaScript in here and I can embed that in my template and then React renders it. Let me talk a little bit about what React is doing under the hood here. And it uses something called the virtual DOM, right? And let's for the sake of simplicity put like a div in here when we talk about this so we can kind of build out our DOM tree. So and while I'm drawing, can someone remind me like what is the DOM in like a couple sentences?
It stands for document object model, and I remember it as a way, if you treat the document as an object, that opens up a bunch of techniques and methods we can use to manipulate it nicely.
Yep. Into objects in browser memory. And then in browser, we have JS interface to interact with the DOM. And what's the structure of the DOM? Is there like a data structure that it uses to organize stuff?
The node tree.
Tree.
Yeah, it's a tree. Right. And so here, our DOM looks something like this. I'm just going to focus on the relevant bits. And let's say useState, let's use effect. And we'll get rid of this to uppercase just to simplify things. And we'll make our box a little bigger. And we'll close out the div. Right, and so our tree has this structure of, let me grab my annotator here. This is our parent of the tree. And then these are all children actually at the same level. And I actually suppose I need to close out this H3. And in fact, if we really wanted to draw it out, we could make it look like this, right? Because this stuff inside each element is in fact a child of our H2 or H3 nodes. And just to sort of draw this out real roughly, there we go. Our div has an H1, an H2, and an H3 as children, right? And then each of those, I'm not going to draw out that it's childs, but it actually has those. And you can imagine how as more and more stuff gets added to the DOM, the tree gets bigger. This is actually inside HTML, right? So all the way at the top here is in fact the HTML element because that's going to be true of every page and it's inside a body and so on. But just to sort of like show a diagram of our tree. And so what React does, and let's go ahead and just move this over a bit. And I think we can safely get rid of this part. React creates a virtual DOM, and this is running in JavaScript, not like in the browser's memory. The DOM doesn't really run in JavaScript. There's some sort of like engine in the browser that does it. And the virtual DOM is modeled with lightweight JS objects, and it's very fast. And then React uses it to compare against the real DOM. That's not the virtual DOM. And I'm running out of space here. So I'll scroll down just a bit here. So, and let me change colors here. So if I was to use a JavaScript object, I could do something like this. And then I don't know, maybe it's inner text or something like that. Or I'm just going to do it like this for simplicity. And then here it's going to be whatever a Pokemon data is. So this is Pikachu. And actually over here, this really should be Pikachu as well, because the DOM doesn't have this templatey stuff, right? The DOM has the actual value. And this is like a really simple tree, but do you see how we can use a JS object to model a tree here? Awesome. And then React uses that to build its virtual DOM. Right? And so it has its own version of this. And let me give myself just a little more space here as I'm about to do some more drawing. So I think I'll scoot this over here. And I'll scoot this just over here, just so we have a little more room. So what happens when in our JavaScript code, I change this from Pikachu to Charmander? Well, React updates its virtual DOM. The actual browser DOM has not been touched. It's not modified yet. And now the virtual DOM has been changed. And whenever the virtual DOM is changed, React does a comparison. Let me make this just a little bit smaller. Right. And the context here is it's actually kind of slow to update the browser DOM. And it can be kind of a pain to do, especially if you have a lot of updates. So what React does is, first of all, it creates a virtual DOM in JavaScript because it's very fast. And then, in fact, under the hood, when React is rendering these DOM elements, I'm pretty sure, I don't know if it's actually adding ID elements, but it's keeping track of them somehow in memory. So it might have something like this, but what React does is it can like quickly access individual DOM elements, and it knows exactly what DOM element it needs to change. So when something in the virtual DOM changes, React compares the virtual DOM against the real DOM. And in fact, it compares the virtual DOM against an old version of the virtual DOM. And it figures out if something needs to change in the real DOM. And then if it does, it only changes the part of the real DOM that needs to be updated. Right? We don't need to rebuild this div or this h1 or this h2. I just need to change the inner text of this h3 element when we go from Pikachu to Charmander. And the virtual DOM enables me to very quickly figure that out and then helps me efficiently make that change. And so this is called re-rendering a component. And a React component re-renders, but React actually does the work of touching the DOM and changing the DOM and only changing the relevant bits. So we are never going to be directly interacting with the DOM now that we're using React. All the stuff you guys have done with document.getElement by ID and document like element.change inner HTML or whatever, throw all that out the window. That's React's job now. And in fact, React does that asynchronously. It actually batches DOM updates. And again, imagine we're building Facebook and like 10,000 tiny things are happening at the same time. As I'm typing a message in a chat, a new user comes online and their little bubble turns green, and someone else's post also shows up in my feed at the same time. So React under the hood actually batches DOM changes, and we don't directly control that. But we tell React what end goal we want to achieve. And this is called more of a declarative approach. The batching usually doesn't matter, but as we get deeper into React, we'll see that it does matter to understand that we don't directly control when the DOM is updated. So I've done a lot of talking here about the virtual DOM and all these concepts. And in just a minute, we're going to see this in action with the useState hook. But I just want to check in to see what questions folks have and what people are curious about and what's on people's minds. How are we doing on like a scale of 1 to 10 here?
8. It all makes sense to me.
All right,
7.
awesome. Love it. So let's see this in action. So just for fun, let me change Charmander back to Pikachu. Watch what happens to this H3 when I change Charmander to Pikachu, and watch what doesn't happen to this div or this div or this H1. And I'm going to save the file now and we'll see the change. So that was the virtual DOM doing its comparison and React identifying exactly what DOM node in the tree we needed to modify and just changing that one DOM node.
It
So
looked like it didn't even change the text Pokemon data. It only highlighted what was Charmander into Pikachu.
right. That is quite possible. I don't know enough to speak confidently at that level of sort of the guts of what it's doing. If we change Pokemon right here to like hello, it's interesting.
It
Yeah,
actually highlighted the first H2.
yeah,
Yeah.
yeah. It may be because React may be identifying that this is, derived, this value is derived from JavaScript. Um, that said, I would just be a little careful because we don't want to read too much into like the behavior of Chrome DevTools, which is not necessarily exactly how React is behaving. But you may be correct. Michael, yes, sir.
I probably was never paying enough attention during like using regular HTML and stuff like that, but what would it look like just as a reference point if you weren't using React? Like the whole thing would refresh?
Well, I mean, it's a good question. I'm not totally sure because we can write JavaScript to grab an individual DOM element. Um, it might be the same, but we would have to do it manually. Like if I did, man, let's see here. Um, what does copy.js path get us? Yeah. So it's going to be hard. Let's see if I can bring up, how do I bring up the console drawer? Here we go. So let's just say element equals that. Let's do L, what is it? Inner text. What's anyone know the difference between inner text and inner HTML?
Inner HTML affects the actual HTML object, whereas inner text only affects the text within the HTML object.
So very similar. We saw the H3 flash there,
Not bad.
right? No, I mean, I didn't know either. Um, in my book, that's what Google's for, right? Like our job isn't to know everything. Our job is to know how to figure stuff out. And it seems to do the same with inner HTML. Which again, we have to be a little careful in not reading too much into this UI. Um, you know, this just ends up being a serious pain. What we haven't seen yet with React is as we have more and more components, and this is bigger and bigger and bigger, we see changes sort of trickle down and we see like multiple changes across the virtual DOM tree. Um, yeah, so Michael, that's a good question. And it's not dramatically different if we're doing it manually with JavaScript. And you could maybe imagine how you'd implement that part of React under the hood. Um, I think I don't want to get too lost in the weeds on that one, also because I'm not sure I can speak um confidently on it. We
Okay.
can
That's okay. I was just curious more than anything. I
Yeah.
already see the benefit of using this,
Yeah.
just like combining HTML and
Yeah.
JavaScript, but it would be cool to see the under the hood.
I'll do a little Googling and follow up later with some more virtual DOM links or descriptions because there's parts of like with the DOM tree, like changes can sort of trickle through the way there's like event bubblings and stuff. But to be honest, I think I would need to look it up a bit more to be able to really speak on it with confidence. So I'll follow up later. Andy, yes, sir. And great question, by the way, Mark.
My question kind of goes along with what Michael was asking. Really, I understand the virtual DOM and then not interacting with the real DOM. But when you did change the name to Pikachu or Hello, we saw it in the HTML, I guess, changed, right? In the HTML document here. So even though we're not interacting directly with it, it's still you're still not manually holding it up from actually executing the change. So I'm kind of confused is what's the purpose of the virtual DOM if the lag between you changing something and being reflected on the actual DOM is like milliseconds, if not, it's not, you know.
Yeah. No, that's a good question. Uh, Part of the answer to your question will come as we start working with useState and other things, and we start seeing more added on top of this, which we'll do in just a minute. I think the other part to remember is that like we're only changing one thing in the DOM here. If we were Facebook and we had many changing things changing all the time, that's when the sort of slower performance of the in-browser DOM starts to matter.
Okay, makes sense.
Yeah, totally. And I think also as we start working with useState, it'll help answer your question. Because really this is setting us up for the next stage. And I think as we see what React does more, it'll help illustrate that. On that note, why don't should we take 5 and then dive into useState, or do you all want to just keep rolling?
Keep rolling.
Okay, let's do it. Yeah, because we're talking about this, we're seeing this. I've been hyping this up, right? I think it's time. So we've got our React app here. We've talked about the DOM and the virtual DOM. We have this useState thing called a hook. I'm going to get rid of this, which is going to cause an error. So let's talk about what this does. This function over here, useState, is called a hook. So we're calling a function. And we pass in Pikachu as an argument. This function returns an array, right? It actually returns an array of stuff. Uh, we'll talk about why it returns an array like this in a minute. One of these things is what's called a component state. We could call it a component state variable, but this basically holds a value, and this is a function to change a value, a set state function. But the convention in React is to destructure that array when we get it here. And state is sort of a general term that you'll see in computing. And it, like, if you freeze a program at a moment in time and you look at all of the different variables in your program and where they are in memory, that's your program state. And that's what you can do with the debugger. So the idea here is this component now has state that React knows about and can control. And note that I can add a default value for that state. It could be an empty string, it could be null, it could be Charmander. And whatever that default value is, and if it's empty, it's just null, this state variable is set to it. And I can then use this just like any other JavaScript variable. And in fact, let's add, I like to add a little message here that shows me when the component renders. And we can see that when I change that, the page refreshed, right? The component re-rendered. And we can use it here, and then we can show it here. So far, not that exciting. This set state variable is where it gets interesting. Because what I can do with this is change that component state. And this, in fact, causes a problem. I forgot about this infinite loop. The reason this is happening is because whenever you change the value of component state, this whole function is executed again. It's called re-rendering. It causes React to re-render the component because our virtual DOM has changed. So this is changing stuff, but then this runs again, and then this changes stuff, and it runs again, and we're caught in an infinite loop. So this was a mistake. But what's a whole lot more interesting and useful is if we had, say, a button, and that button had an on-click event, and what that did was change the value of that component. And you can see here when I clicked that button, our page did not refresh, but this function ran again. This component was re-rendered, and that because we changed this state value. So React pays attention to this, and if it changes, it will re-render the component. It will call this function again. It updates the virtual DOM. It compares it to the real DOM, and then it changes the real DOM if it needs to. And this is very powerful, right? Because now maybe I want to do something like this. Maybe we want a form, and in here we've got this stuff, and maybe on submit is going to be where we actually will. Let me refactor this a bit. We'll add more stuff in. My apologies. Let's have an input field. And in here, let's show our Pokemon data. And let's see, what did this not like? Input is a void element tag and must neither have children. Oh, I'm so sorry. This should probably be value equals Pokemon data. There we go. So this is not very interesting, right? In fact, let's have this start as an empty string. Let's add an onChange handler to this input field. And let me format this so it's more readable. And let's see what this red squiggly is that it doesn't like. Oh, it wants me to just not have this closing tag there. And now we're going to have something much more interesting happening. So I'm typing in this input field, but every time I do, this onChange handler is triggered, which is calling this setState function, and we're updating Pokemon data. And in fact, let's go ahead and up here also show the Pokemon data. And this is where we can start to see the power of React, right? Because this useState hook lets me create this special variable called component state that React pays attention to. It gives me a special function called a setState function. And whenever I call this, I can set the value of this. And React is watching, and it knows if this changes. And if this changes, it runs our component again, it runs the function again, and it checks the virtual DOM from what's returned here. It re-renders the component, and it sees if anything needs to be changed. And this means I don't have to do all of that document.getElement by ID stuff. Instead, what I want is I want to create, this is called component state, because right now our app only has one component, this app component here, but we will soon have many components and we can create a whole bunch of state in each one. I don't really need the form here, do I? So I can have a bunch of different state. And in fact, it'd be nice if I could like toggle this somehow. Um, it wants a type prop. That's fine. Uh, so maybe instead of like putting the actual message in here, I want to put a Boolean in here. And let's do something like const message, we'll call it display. And if message status is true, we'll display hello. And if it's false, we'll display goodbye. And then over here, what we can do is we can set the message to its opposite. And really, I should rename this as well for consistency. You always want this to be the name of your component state and this function to update it to be named set and then whatever the name of it is. And it looks like I have an error. Message is not defined. No problem. It looks like it's on line 25. And now I have a toggle. right? So you can do all sorts of interesting things with state. Let me just pause and check in and see what questions have and what things people are curious about because I've been going on for a minute here. And this is like our bread and butter. We're going to be using so much component state over the next week or so. So this is a great time to fire away with any and all questions. How are we feeling about this?
Would there be a time where you would not want to use component state and instead just want to do the document, whatever?
Yeah, great question. The answer to that is a very hard no. And the reason is if I change the DOM, React doesn't know I've directly changed the DOM. React only knows about the virtual DOM, about its own virtual DOM, right? And so by using state, we can tell React these are things that you should pay attention to. And if they change, update your virtual DOM. Because this is how React sees the universe, right? When I create component state somewhere in the guts of the React.js library, it's keeping track of this. And when we call this set state button to change this, it knows it's changed. And that's how it knows to re-render the component to call this function again, which is how we get interactivity. Right. And if we interact with the DOM directly, we lose all that. And it's like a black box to React. And it's sort of like using the tool the wrong way. Right. Like I can hammer a screw into a wall and hang a painting on it, but that's not how I'm supposed to use a screw. Right. I'm supposed to use a screwdriver with a screw, not a hammer. Does that help answer your question?
Yeah, it's perfect. Thank you.
Yeah, absolutely. Yeah, no, and that's a great question. Every now and then there's an exception to that rule, but it's extremely rare. What other questions do folks have, or what else are people curious about with state? Okay, let's see maybe one more thing with state, and then we'll take a break. This is important because this is going to be a common pattern. We're going to see how we can use state with a list of objects. And I'm going to make some really simple tasks here. This is really just a proof of concept. Oh, excuse me. And let's make this one false just for fun. So I've got some tasks here. This is, yeah, you know what? Actually, I'll pause. I think we'll come back to this later because we haven't really talked about mapping with components yet and stuff. And I don't want to open that door. So instead, let's build the counter that we saw in the Vite example. And you should always put your component state up front in the beginning of your React component. And this is going to be a little button where every time you click on it, it increments the value of the counter by 1. So let's add a counter. And then below that, let's add a button. And this button's job is to set the count to counter +1. right? And this is what we saw in that V template. And I think this also hopefully illustrates the power of React and component state, because you can do this with document.getElement by ID and stuff. But once you get comfortable with this, it's a whole lot easier with React. Look how much interactivity we have on this page, you know? And if I want to do something like, um, you know, all my states, and it'd be much nicer to have this be maybe a paragraph or an unordered list or something. But look how much interactivity we have on this page, right? So now all of a sudden we can start to build really interesting, complex user interfaces. So let me just pause and see what questions folks have, and then we'll take a good break, and then we'll take a look at useEffect. What's on people's minds, if anything, with regards to state? Okay. I think the weirdest things are we don't directly control changes to the DOM anymore. React does. We're driving React, and React is driving the DOM. And I think that's important to remember. And React builds with JavaScript objects this sort of really lightweight virtual DOM model, excuse me. And that's what's happening over here, right? All of this really constructs the virtual DOM. But then whenever state changes, component state changes, React compares. And we'll talk about a component's life cycle a bit later. And this is a terrible, terrible drawing of a loop. Please forgive me. But the idea here, and this is where the name React comes from, is an interaction happens and React checks if state has changed or if something has changed. And if it does, it re-renders. And we have this continuous loop. And that's called the component lifecycle. And that's, I think, a little tricky to wrap your head around, but that's one of the key concepts here. Nick, yes, sir.
You said that the old state of the virtual DOM is compared to the new state of the virtual DOM, and if there's a change, then it updates the actual DOM. Can you show a quick little example of a change we make in the program that doesn't affect the DOM so I can see it, or that doesn't affect the virtual DOM so it doesn't cause an update in the actual DOM? I I think it's probably really, really simple, like just
Yeah.
manipulating some stuff up outside of the return. Is that right? But don't
Yeah.
affect anything inside the return?
Yeah, pretty much. I mean, if I do, and you actually touch on a good point here. Actually, this is not going to be a great example, but so the thing to remember is, and let me go ahead and let's go to our app here. And let me refresh the page and let's actually talk about the flow of execution. So when React first starts, for the very first time, the React application is mounted on this DOM element, and this app component, it's called rendering, right? And this function is called just like a normal function would be, and just like a normal function, execution happens top to bottom, right? We create some React component state, but nothing is returned or rendered. More state, more state. React is like, okay, I'm going to have to keep track of these. We see this console log statement happening. We see this other console log. This variable is created. I create the variable X, whatever. Then the function returns. And this is where React sort of does its magic. And it constructs the virtual DOM. And then it must compare it to the real DOM as well. And I'm not exactly sure the mechanics of when it looks at previous virtual DOM versions versus the real one, because there's a lot of like caching and efficiency stuff that happens. But React says, hey, none of this stuff exists the very first time this page loads. So let's create all these elements. Right? I mean, and it happens too fast for us to see. So all this stuff is created and done, and then this function is finished executing, right? It's returned. And the tricky bit here is that none of this stuff happens again until I do something that modifies component state. Like when I click on increase count, so if we look at the counter over here, if I click the button, it calls this set counter function. Increase count, or it's the set counter, all it does is change the value of this. But what that does is, because React is watching all the component state variables, React sees this has changed. And then React says, hey, this component has changed. Its state has changed. I need to re-render it. I need to call this whole function again. And you can see right over here where there's app that console log has happened again. And then it doesn't recreate this use state stuff, I don't think. But we see this console log, we see all this stuff, and it returns this again. And then somewhere under the hood with the virtual DOM comparison, it's being clever and figuring out that the only thing has changed is over here. So like these DOM elements don't get messed with, but then this one has changed. So it's a little hard to show something that doesn't change the DOM, because components only re-render when like component state or something that potentially impacts the DOM has changed. Like
From
if we
here,
wanted to, actually what we could do is I could comment this out and I could remove the counter from here. Actually, this could be good to see. And this would be, I'm curious to see what happens here. Let's refresh our page. And if I increase the count, note that even though the count is not displayed anywhere, because that component state has changed, the component is still re-rendering. And we can tell that because we see these console logs. But we don't see any actual changes to the DOM. Like, let me go ahead and click on increase count. Right? That component is re-rendering. React component state is changing. But React says, hey, the virtual DOM hasn't changed, so I don't need to update the real DOM.
would you go to the console again?
Yeah, absolutely.
Refresh the page, please.
Yep. I love it.
And then would you change let x equals 5 to let x equals 6 over there
Sure.
on line
There is going
17?
to be one issue with this. When we change the JavaScript code, that triggers Vite.
Okay.
And Vite's web dev server hot module reloading, and I think
It's
the
gonna
whole
hot
page is
module
gonna
reload it, okay.
refresh. Yeah.
It's gonna crash?
Refresh. Sorry.
Refresh. Okay.
Yeah, and that has nothing to do with React. And we can
Okay.
actually see that if we go to the network tab here and we clear it. If I change like x equal 5 to 6 and I'm going to save it. This, whatever the heck all this stuff is Vite doing hot module reloading and loading in the new code. And in fact, we see Vite hop dated source app.jsx. So that's actually not React at all. That's Vite's dev server for our productivity. Does that help answer your question though?
Yes, that answers it.
Totally. And actually, it's a great point to see the Vite hot module reloading, because there is a lot of stuff happening here, right? So that's actually a really good distinction to make. Um, let's take a break because we've been going for a while. My desire to have like an hour of work time may be a little over ambitious because we still have to take a look at use effect. So I do apologize. Why don't we take, you all want to do 10 or 15?
10.
Yeah, okay. Let's take 10. And when we come back, we'll take a look at use effect, which is going to sort of build on this. And then we can dive into really looking at like different components and building on this. So thank you all very much, and I'll see you all in 10 minutes. All right, we've been talking a lot about state, and over the break I wrote out like a sort of toy version of this use state hook, kind of just to help think about it. It's returning a function, right? And it's creating a value of initial state, but by enclosing that initial state value in this set value function with a JS closure that we had talked about the other day briefly, it means set value will update the state and then it returns the two in an array. I'll kind of just leave this here if we want to look at it later. So we've spent a long time talking about the use state hook. We've talked about the virtual DOM. We did our review. Now we're diving into use effects, which is where things start to get really interesting. Because state is great, but what if I want to make an API call? What if I want to get data from the Pokemon API? What if I want to, have some Pokemon data? Um, and I'm just going to refactor this a bit so that we have not just Pokemon data, but let's just call it Pokemon name. And we'll make it an empty string, and we'll make this empty. And it looks like I have an error over here.
You didn't close the, yep.
Yeah, thank you. And I just want to change this to set Pokemon name. And let's change this to Pokemon name. And let's change this to Pokemon name. And I just want to make sure everything works. Yep. And I want to add another button. Right? And this is, we're going to get the Pokemon data. And I think we're going to need to write a function for this. And I'm just going to put a placeholder here for the moment. And let's hook this up to our button. And we should probably call this get Pokemon data. And actually, I guess we don't need that. And we just need to rename this to get Pokemon data. So I've got a button. When I click on it, we're going to build our API call to get Pokemon data, which doesn't exist. And we've seen how to do this. Though I probably need to install Axios. So let's quickly do that. npm install Axios. I don't think we have any problems, but let's just double check. Yep, that's just a warning. So let's run our vite dev server again. Let's import Axios up here. And then over here, we can now start building our get Pokemon data function. And of course, it's going to need to be an async function because we're making an API call. And we're going to do an Axios get call, and it's going to go to the Poke API. And in fact, let's do it like this. I'm actually going to build our, let's call it the Poke URL. And I'm going to use a tagged template literal. And we're going to put the Pokemon name in here. And I wanted to do it here so I can console log it in case I make a mistake. I really like being able to console log stuff for debugging. And in fact, let's just go ahead and put Pikachu in here and check that everything looks good. Let's in fact click on this link. Looking good, right? And I really love developing in small, tiny chunks where I can informally test like this as I go. Because now before I move on to the trickier bit, I know my code is good and I've like actually verified it through an informal test. And now let's make our Axios call. It also makes this next line of code a bit shorter and easier to read. And because Axios puts the response data in this data property on the response object, let's see how we do. So,
Do you need to wait in front of your Axios.get?
I absolutely needed a wait. Thank you so much. That was not an intentional error, but it would be perfect if it was. And in fact, that's a great example of the problem with not having an await. And in fact, if we put a console log for response.data here, let's see what happens when we click on get Pokemon data. So this is a great example of why we need the await. Even though this is an async function without it, JavaScript prints out this console log on line 30 before this HTTP request has gotten a response back. So I remember we were talking about that the other day. Now let's try it and see how we do. So this is great. We're hitting the Poke API and we're getting tons of data back for Pikachu. There's images. We can do some cool stuff with the images. We can do all sorts of good stuff, right? And now the next question is, how do I use this and put this data in my React component? It'd be really nice if I could say, show an image of my Pokemon data. If from these sprites here, maybe we can show like the front default image. Oh, well, this URL here, which shows an image of the Pokemon. So like over here, I want an image tag and I want the source to be, well, this is where it gets tricky, right? What is this source going to be? How am I going to get my information out of this async function and into here? This is not quite a trick question, but it's in that territory. Anyone have a guess? How can I get the data from this response out of my async function and into this return statement?
You make a global variable, set it equal to null, and then inside of that async function, you're going to set whatever pokey data that you want to get out of it to that variable, and then you can use that variable and like access into it.
Yeah, I love it. There's a couple things we're going to have to tweak with this, but we can create a variable outside the scope of get Pokemon data, Pokeimage URL. And then inside of it, we can set Pokeimage URL to response.data.sprites.front. Let's see what it is. Front default. I think that should do it.
Sprites is misspelled.
Thank you. And my autocomplete ran wild with me there, unfortunately. So let's try that one more time. Response data sprites front underscore default. Let me escape it before the autocomplete tries to do something crazy. And let's do my favorite thing. Let's make life simple. Let's console log it and see how we do. And then over here in the image element, we can do Pokeimage URL. And let's see, what is this squiggly here telling us? Provide a text alternative through the alt. Okay, we're not going to worry about the alt image. So let's see how we do. Well, we did good, but we have some problems. The Pokeimage URL doesn't seem to be there. All right, let's console log here.
Yeah, we need to return it, right? Or get some way to get it out of get Pokemon data and into the rest of the function.
Correct. Yeah, we would have to return it.
Well, you can't really return stuff outside of an async function. Everything is sort of self-contained, right? That's kind of the nature of an async function, because I would have to wrap it in another async function that captures the return, I think. Or like what would, and because I call it when this button gets clicked over here, and we shouldn't have to return because we have the image URL variable here. And it's there if I, let's refresh the page. So, and let's just put, bad in there just so we can see. And this is actually good because we can walk through the flow of execution here. Our component has rendered for the first time. All this state's been created. We have this Pokeimage URL variable. It's not set, right? It's got a bad value. That's our default value. But we see the, it's printed here. We see the broken image URL up here, if you guys see where my mouse is. And the component's rendered. Now, if I type in Pikachu and hit get Pokemon data, and let me go ahead and clear all this. We see we make the API call, we get the successful response. We see here inside our Pokeimage URL, our async function, that in fact we've gotten it, but then it's done. And in fact, we don't see this console log here. And React doesn't re-render anything. And if I go here and we kind of open this up, we see nothing's getting re-rendered. And the problem is React doesn't know what's happened, right? Let's make this component state and see what happens. And so we'll get rid of that here. And we'll have to change this to set pokey.
It's lowercase p, I think.
Yeah, thank you. Set the image URL. And let's see what happens. So, right, because we had it as a global variable, but React didn't know that existed. It didn't know it needed to re-render stuff. Maybe stuff will work now. So this works. We have a couple issues here. The Poke image is working. We haven't updated Pokemon data, but we can get there. But there's some problems here. We're actually not really controlling the flow of execution the way we need to. This is working, but we're not getting necessarily guaranteed that this will finish before this renders. And that's where useEffect comes into play. Like this will work, but it's a little bit like playing with fire because we don't know how long this asynchronous operation takes. We know that this state gets updated and React re-renders when it does, but we want to give React even more control over this asynchronous operation because it's something called a side effect, meaning it's not about like changing the component state, like we're reaching outside of React to do something else. We've gotten really far here, but our last bit now is going to be to use the useEffect hook. And let's also actually, as long as we're doing this, I think we should also set Pokemon data to response.data. And we can console log in here, Pokemon data. And let's console log here too. Pokemon data. And we'll probably have to change we'll have to change this part right here showing Pokemon data. It's probably Pokemon data dot name. Let's see if that does it. Cannot read properties of undefined. So now we're running into some other issues here. So actually, before we even get to use state, we have this problem where I want my Pokemon data to be an object. But we haven't even gotten that object. It doesn't exist yet. So we can use the ternary operator. And I can say Pokemon data. If it exists, show the name. Otherwise, show no. And we can do the same thing here. And we can say Pokemon data. If it exists, show the name. Otherwise, show no. And that fixes those errors, right? Because right now, and let me refresh the page so we can get a clean print of the console logs, that Pokemon data is undefined. And in fact, I could do this for this whole image element here because the Pokemon image doesn't even exist. Let me, in fact, wrap this whole thing in curly brackets, and we'll do Poke image URL. If it exists, we'll render that image. If it doesn't, we'll render null. And I will go back up here. And I forgot an E. I have a typo. And this is no longer helping us. We want this to be empty. And this is nice because now we don't have that ugly broken image. And now if I type Pikachu, We see, all this stuff is undefined, but our ternaries handle that for us with a nice pattern. And if I hit get Pokemon data, we've gone ahead and we've gotten our Pokemon. Though something really interesting has now happened in our console logs. If we look at line 35 and 36, do you guys see these console logs that I'm pointing to here? Right after we've updated this state, right after we've gotten our data back, they're both null. But then when we re-render the component, which we can tell is happening because there's this console log of the app coming from line 20 right up here, because we've changed component state, we see these print statements on line 39 and 40 have our data. And so, you know how I was saying earlier, React batches state updates and they happen asynchronously? This is a great example of that. Just because we call set Pokemon data and set Pokemon image URL here doesn't mean those things happen instantly. React batches and decides when to do them, and it's waited enough milliseconds that the flow of execution has gone on, and it doesn't exist yet for these things. Now it triggers a re-render, and by the time that this is done, it's there and it exists. But I think this shows under the hood a little bit how there's more stuff going on with React and it's more asynchronous, and how it would be nice if we could get a little more control to make sure that we never ever render, this part until this has completed. And that's where the useEffect hook can come in. And with the useEffect hook, there's going to be two things that we do. And one moment here, I apologize, as I am looking at my guide code. There we go. Thank you for bearing with me. So what I'm going to want to do is I'm going to actually want to call the get Pokemon data from a useEffect hook. So let me go ahead and import it. And then down here, we're going to use it. And it actually takes two arguments. The first argument is a function, and we're actually going to wrap our get Pokemon data call in an empty arrow function. Like that. But this actually causes a problem. I don't know if we can see it here. If you guys look at the console log, it's going up, 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 up on the right. We actually have an infinite loop going on. Every time this component renders, it's firing this useEffect. React will actually execute whatever is in the useEffect. And let's actually see this in action with a console log. And it's not refiring right now because we're not changing anything. But let's say I do set Pokemon image URL to hello. We've got it rendering once. And my apologies. I thought we would get an infinite loop here, but it looks like it just happens the one time. The get Pokemon data scenario is trickier because I think it's changing things that are changing, that are causing a re-render that's causing it to change again. I wonder if we do set Pokemon name here. Yeah, it might cause some other issues. But the way we can control a use effect is with its second argument, which is what's called a dependency array. And what this does is it tells the use effect when to fire. It's a function that takes in two params. And the second one is a dependency array. And you can put in here a bit of component state. And then whenever that component state changes, the use effect fires. And in fact, let's comment this out so we can see this a bit more clearly. And we can see here, every time I'm typing in here, the use effect fires. So this is nice because this is another way for us to control stuff in React. Now, I don't really want this use effect to fire every time like I type. What I want is I want to type in the Pokemon's name, and then I want to hit like get Pokemon data. So I think what I'm going to do for the purposes of simplicity is we're going to just create a little bit of component state, and we're going to call it is fetching Pokemon data. Or we'll just call it like let's just call it is get Poke data. And we'll set it to false. And we'll have the use effect watch that. And over here, what we'll do is this button on click, we'll just set that to true. And it's like a little switch that I can flip. And now I can type in Pikachu. I can still have my component controlled. But now if I click get Pokemon data, it fires that use effect. And it looks like I might need to, in fact, have this. This is a little hacky. I apologize. The better way, there are better patterns, but we're just going to flip the Boolean to toggle it back and forth so that now every time I click, it fires the use effect. Right? A better way might be to like only update the Pokemon data when we click get Pokemon data, but that's a little out of scope. And so now I've got Charmander. I can hit get Pokemon data. It gets the data. Let's also see what this means for those empty messages. And if we look here on the print statements from line 36 and 37, which are over here, we now see that they have values every time. And again, let's see, here's the line 36 print statement and the line 37 print statement. These were the ones that were coming up empty before. And now what we're able to do is, because React controls when this HTTP request happens, and React knows that it's a side effect, it makes sure that it doesn't continue the flow of execution until this is done. And let's see what these red squigglies are here. This hook does not specify all of its dependencies. This hook specifies more dependencies than yesterday. Yeah, so we can, we don't need to worry about those red squigglies. Nick, yes, sir.
Line 48, since the dependency array is an array, can you have more than one thing that it's watching before it runs the function?
Yeah, you absolutely can. Um, let's comment out the API call so that we don't get too much happening at once, and let's put the Pokemon name back in, and let's go ahead and clear this. And so we see that there's now, it doesn't wait for both in the dependency array, it will act on either. Does that make sense?
Yes.
Yeah, great question. The other nice thing about useEffect is React guarantees that they happen in the order that they're declared, and you can have more than one. So if we wanted to do something once Pokemon data has been updated, we could in fact have it watch the Pokemon data bit of component state. And so let's say here I type in Pikachu and I hit get Pokemon data. Let's see what happens if we look at the console logs. We in fact see a couple interesting things. We see the useEffect fired for get Pokemon data. It does all of its things. It renders. And then we see all the way down at the bottom here, this Pokemon data has been updated. That's coming from this console log in the useEffect that's getting triggered because this useEffect gets the Pokemon data, that updates the component state, and then when that happens, this useEffect fires. So you can use this to like chain logic in a very controlled fashion. If, say, we wanted to make another API call for some reason, or maybe instead of doing this kind of ternary, like let's say we have another bit of component state, uh, show special message. And over here, we could set show special message to true. And over here, we could do something like if show special message is true, let's just put in a paragraph tag that says, special message. And it looks like, what did I do wrong here?
Do you need to have it wrapped in a div?
No, I misspelled my setter function. I just wrote show special message instead of set show special message. Just the paragraph tag right here is enough. And in fact, we saw that happen awfully fast. So let me refresh the page. Interesting, because I don't think this one.
Does,
I did something wrong in my logic.
Pokemon data always changes, right?
I thought we were only changing Pokemon data when we make the API call to get the Pokemon
Oh, no,
information.
you're right.
Yeah, but I've done something silly here. Let's see if we can figure out what it is. If we look at the console logs, so Pokemon data is undefined. so on, so forth, still undefined. Um,
Your first use effect gets Pokemon data. I don't know.
yeah, yeah. This one, it shouldn't be firing yet because I don't think we've changed like is get Pokemon data.
But you have the my use effect console logged in there. So your use effect is firing off, which then does get your Pokemon data, which then would fire your second use effect.
Yeah, yeah. I it's which is interesting because I thought we had it, not doing that just a minute ago. So I wonder if I changed something. Um, let's see if we can debug this. If not, we'll pause and I'll debug it offline. We've got Pokemon data, we've got about to render, we've got Pokemon image URL, and then we do go into my use effect. So there is, let's see here, has a missing dependency.
For your thing, aren't you just doing if show special message exists for your logic down on line 68? You're not checking if it's true or false, you're just checking if it exists, right?
Well, in JavaScript, existence is truthy or falsy.
Hmm.
Setting this as a Boolean. So they sort of serve the same purpose here, if that makes sense.
Yeah, it does.
Yeah, that's a good thought though. And in fact, we can comment that out as well, just to be safe. There is sort of a counterintuitive behavior of use effect. And let's talk about that because I have a feeling like that might be related to this. And let me make sure I'm not calling this anywhere else by mistake. Nope. So the weird thing about use effect is this dependency array. You always want to provide it even if it's empty, because otherwise you can end up with an infinite loop. Because this is how we tell it like fire once and do nothing. But the very first time a use effect fires, it fires after a component renders. And if we refresh this page, what we see is the app, we see the rendering, and then after the very first render, the use effect fires. So sometimes, like if you want to grab some data on initial page load, you might use this pattern, but you have to sort of render a loading message until the use effect fires to get the data. Now, why this is happening here is confusing me a little bit, and I do think I'm going to Google that error message real quick. Um, and see what the internet says, because I feel like this might be related to this. Um, and this actually might be the answer, is that we should just and in some ways this might be a better pattern, is we should just move this function definition inside the use effect. And I wonder if that's the issue. I'll share this link. Also, the guy who wrote it, Dan Abramov, is on the core React team at Facebook. But let's see if moving this inside solves the problem. And this has other advantages
mandatory
as well. And let's see what happens now if that resolves it. Nope, so it's still run. Well, actually, let me add in here, is interesting. Has missing dependencies, Poke image URL, Pokemon data, either include them or remove the dependency array. Yeah, I'm not sure about that warning. We'll have to see. Let's see how we do now. It looks like I'm still running into the same issue, which is a little surprising because I think we actually had this working before. So my guess is I've done a lot of modifying of this code. I think I may have introduced the typo that I didn't realize. or like a logic error. And that does point to like this stuff can get a little tricky, but it is extremely powerful, right? Because it gives you just a lot of control. Scott, yes, sir.
That squiggly in your dependency array is just like a heads up that you're not passing in some of your other state variables that it thinks that you might want to use,
Yeah.
which you don't. It's just that's what it's saying basically.
Yeah, that makes sense because it's seeing that we set these state variables here and here.
What data type, oh, sorry, is get Pokemon data?
It is an async function and it's not actually returning anything. Are you thinking about the Pokemon data itself in component state?
Well, because if it's triggering, that means the program thinks, if the use effect is triggering, that means the program thinks that something inside of that array has changed, right?
Uh, yes, though use effect also fires if we don't have anything in the dependency array, it fires once by default when it loads. So we may
Yes.
need to,
Once again, I'm just reading online. It's talking about reference by quality versus reference versus value. It says that
oh,
if a dependency in the array is an object or an array, the new object array in the same with the same content, it triggers a change even though the values might be exactly the same. I don't know if I have no idea if that's it, but that's, seems to be a common issue.
right, right is what it calls a shallow comparison. Um,
Because here, just from my understanding, so a use effect only triggers when something in that second argument, which is an array, it changes, right? Or at least it thinks it changes.
right.
Is that
With an empty array, which is often what we do, it runs once after initial render and mounting and never again, which is not what we want here. If there's no array, it'll call after every single render, which is not what we want. And what we want is exactly what you're saying, where we have a specific state value. And the one I had in here was this, I kind of made this up just as a Boolean that we could use. And is get Pokedata is set to false initially. And then I was thinking when we click this button, it sets it, it flips it from true to false, and that's sort of our trigger for the change. Um, but you raise a good point. We should console log is get Pokedata. And then after this, I think we should break because I've been debugging this one for a while. And I think we should take questions and break so that then we can look at some other stuff with components. And but I am curious to see if, and I didn't mean to interrupt you if you're at a follow-on thought.
no, that was it. I'm just
Yeah,
trying to
no,
figure this out too.
yeah, no, it's a good thought. And this is where the console logs help because we can kind of see the flow of what's happening. So this is where our app component starts. Pokemon data is undefined. Is get Pokemon data is false. And we see that here on line 24. And then we see it here on line 52. And then we see we're about to render and we haven't fetched any Pokemon data or anything. So we expect all of that. And then it fires the use effect, which is a little confusing. Um, and this is why I kind of keep coming back to this warning because I'm wondering if something, if I'm misunderstanding the behavior here. Let's try because it is a little confusing that this warning happens. I don't think this is gonna work. I think this is gonna cause problems, but I'm curious what happens if we try satisfying this. And if we refresh the page, what happens? This is going to introduce other problems.
It looks like there's something going on behind the scenes with useEffect, and it looks like there has a value is mounted, and for its initial rendering, um, its mounted will switch from false to true. So it looks like if you want to prevent that initial one, you have to set is mounted to true prior to it loading.
Interesting. Say that again.
So it seems like just from what I'm reading, that the is mounted, it like has a value. Is mounted dot current will either be false or true.
Mhm.
For its initial loading of like launching everything, it'll be false. So then it causes that use effect to be triggered to just mount it in the spot, and then it'll swap that is mounted dot current to true.
Okay, interesting. I'm not sure to be honest. If that's what's impacting it here or not. I think I need to take this offline to try and debug it. And we need a break anyway. I know my brain is getting a little fried. Like in theory, this is how we should be telling the use effect if it's firing on mount or not. This would mean fire after is mounted. And my understanding is this would mean like fire after it's mounted. I do wonder if by using the Boolean false, if that's causing us a problem, which would be really annoying and unfortunate, but I kind of doubt that. Yeah, we still have the same thing. Let's take a break. I think we're better off, like we've seen like use effect in action. Let me take a little time to see if I can't fix this offline. And then when we return, we can do a brief review, but then we're going to really dive into creating multiple components and props, because those are really the next big building blocks that are going to set us up to do lots of interesting stuff with React. Sound good? All right, folks, thanks for helping me with this. My apologies that we weren't able to get it. If I can, I'll get it during the break. But let's take 10, and then when we come back, we will look at components and props. Thank you very much, guys, and see you all in 10 minutes. All right, so the good news here is we had this issue where I had this use effect and it was firing all the time. Well, with the help of asking the AI some questions, and in fact, just let's pull Chat GPT up here so we can kind of watch this. Does use effect always fire on mount, even if we have something in the dependency array? And we'll hit this. So this is what I did wrong. My brain just got a little fried. Use effect is always going to fire on mount, even if we have something in our dependency array. And that was the problem that I was running into, is that as it says here, React will always run the effect once after the component mounts. And then it uses the dependency array to see if something changes between renders. So the solution to this, and I did get this working, is if we look over here, and I'll bump this code up a bit. That's probably too much. I added this if statement on line 36, and I renamed this component state, so it's just called should fetch. And so now the use effect is going to fire a bunch. It's going to fire on mount. It's going to fire when this changes, but I added an if statement inside of it, and this is a common pattern. And this checks if should fetch is true or false. And then it only executes our asynchronous function when should fetch is true. And then what we do is right away we set it to false while we're still inside the use effect so it doesn't re-trigger everything. And so then should effect is always false. When I click on the button, it's set to true and that fires off the call. So if I refresh the page here, we can see this in action. And we see the app loads, our stuff is undefined. We actually see the use effect console log message, which I left up here, but we do not go inside the if statement, right? And in fact, as I type in here, Pokemon name, all the stuff we would expect. And then we see the use effect fire. We see Pikachu show up. We see my use effect, and that we're actually then inside that if statement. Then we set should fetch back to false. And then if I type Charmander, we get the same thing. And now this other use effect, well, I'm not even going to worry about that other one because we'll run into the same issue that we need to resolve where it's going to fire once. It would, I think we'd have to do something like this if Pokemon data. Yeah, I'm not even sure if that's going to work. I'm not going to worry about that right now because I think we have enough ground to cover with stuff. So I just wanted to show that to folks, and I think now is a good time to, if we have questions around useEffect, to tackle them now before we switch gears.
So useEffect always triggers on mount. Then
Yeah.
afterwards, it's going to look at the values inside the watch array or whatever it's called.
Yeah, that is correct.
Okay, dependency array.
Correct. Yeah, that's my bad. And if the watch array is empty, it only fires once on mount, which is really useful for like initial page load, but then it will never fire again. If there's no dependency array, it will fire after every single render, which is almost never what you want because you can end up with infinite loops. What other questions do folks have, or what else is on people's minds? Okay, cool. Let's switch gears. Let's talk about components. Again, I apologize. We got a little lost in the sauce there, but I think the silver lining is we're starting to burn React into our brains. So we've spent a lot of time with useEffect. We've seen conditional rendering. Now we're really going to talk about components and props, and that'll take us to map and filter. And for this, I am going to just spin up a new Vite project for us so we can have a fresh start. So I'm going to do that real quick. I'm going to install Axios just in case we need it. I think this is also sort of a nice palate cleanser for our brains. We'll pull up the empty Vite project here. You'll almost always want to go through this sort of habit of what I'm doing now of the Vite has all this default stuff in its template, and we just want to get rid of it, frankly. So let's talk components and props. A component is a self-contained reusable piece of user interface. It can contain both JS code and JSX. Right? It can have both logic and layout. Components are the building blocks of a React application. Why do we care about components? So we don't have to repeat code to help isolate code. And we'll also see because components power props, which are another way to control the React component lifecycle. So let's see how to use components. I'm going to make a directory, and this is just convention. This is not required. We're going to name it components. And inside there, let's make a component and let's name it, oh, how about component info.jsx. And we're going to export default function named component info. It's going to return, for the moment, let's just have it an H2. We'll just call it component info. And that's all it is. Let's go ahead and let's import, just like any other JavaScript file, this component. And React and VS Code gives me some really nice autocomplete. The naming convention is like Python classes, components should be camel case with uppercase first and last letters. And inside here, let's go ahead and let's use our component info component. And I can do it just like that. And if I look at the elements tab, right, way more chill than useEffect. We see this rendered here. There is a great extension for Chrome I recommend you all get called React DevTools. And when you install it, what you get is over here in the developer tab, there is now a components tab. And I can see my component tree. And I can actually, we'll talk about props, but I could also see state here as well. For instance, just for fun, if we do a little bit of this and we do const, and we'll just call it maybe component info list. And we'll set it to an empty list. And we're not going to do anything with it. But if I go to my components tree, we see here the state and we can see what it is. So there's going to be some really cool stuff that we add on here, but this is like the essence of a component. And I just want to pause and check in and see if folks have any questions before we start building on this. Cool. So Now that we've got this component info list, let's take this stuff and instead of having it be here, let's put it here. And I think we can get rid of this. And we can leave it like that for the moment. And we'll come back to this in a minute. But you can make a bunch of different components. You can even have components inside other components. Like maybe I want to refactor this. Maybe I want this to be an H3, and we just are going to call this components. And we'll call this the overview. And we'll call this the components when to use and why. And I'm starting to see a pattern here, right, of an H3 and another unordered list. So why don't I make a new component? And we'll just call this like info subsection. And you can use Emmet if you guys have used it with HTML with something called a React functional component, where it will just sort of give us some nice boilerplate. And I always get a little confused with how to do it, but there we go. And we don't really need that there. And let's have this. I like wrapping everything in a fragment just out of habit because it doesn't hurt anything. And let's just grab this components when to use and why. And let's put it here. And then over here, let's import the info subsection. Note that this is a relative path up here because we're in the components directory, because this is defined in the components directory. This is just /. So this is like relative file pathing. And let's use that component right here. And so if I go to app, I only have this one component, but that component uses another component, right? And if we look at the DOM tree, it looks all the same. But if we go to the React DevTools tab, we can see our component tree. And so this component, remember, this is a function that returns stuff to be rendered. So I can have a console log and I can have it say components info. And these don't do much. And we'll have this one say, info subsection. And we'll have this one say app. And if I go to my console log and we refresh, we see those statements in order. We actually see this print statement happening twice. You guys see that? This whole thing is getting rendered twice. That's actually what this strict mode thing does. It's useful for debugging certain things, but for us right now, it's more of a pain, and that's why we say to get rid of it. And now we see everything just renders once the way we would expect. So let me just pause here and check in and see if folks have any questions. How are we feeling about components thus far? Pretty good? Nice. Now, like a good rule of thumb is like think about design and sort of like strict layout and like visual layout before thinking about logic. And in that vein, there's more that we can add here. There's parent and child components. parent component is a higher level component that renders one or more child components. And let's see, what did this not like? There we go. And the child component is a lower level component rendered inside a parent component. A component can be parent and child at the same time, right? And a great example is this component info component. If we go and we look at our components tree, it is a child of app. App is the root component, the ultimate parent component. This is a child of app, as is info subsection, but this one is also a parent to info subsection. And why does this matter? This matters because of props. Props, aka properties, are arguments we pass into a component as function arguments. They are exactly like normal function arguments. React bundles up props into one object that's passed in as an arg, traditionally called props. And we normally destructure the props object. So let's in fact see this in action, because it'd be really nice if I could have one component to use to show this prop stuff and this component stuff. So I have an info subsection. Let's make a component called an info section. And I'm going to cheat a little bit. I'm going to go over here to our component info component. I'm going to grab all of this, and we're going to go here, and we're going to put it here. And it takes an object called props. One of the arguments that's going to be in this object is going to be a title. And there's not a lot happening here yet, right? If I go here to app.jsx, and excuse me, because I made a big mistake there. I should not be using the file searcher. It took me to the wrong part of the lecture. Here we go. So let's not use this components info component anymore. Let's import our info section. And let's use it right here. Now, let's see. We get an error, unexpected token in the info section itself. This looks more like a typo. And if I refresh the page, I may need to restart the dev server here. And if we refresh the page. So now we have a different kind of error. And this is why it's important to keep the console open with React. Info subsection is not defined. That's fine. We'll worry about that later. So now if I go to app.jsx, I've got my info section. It's, it's not that exciting. It's displaying all this components information. I think I'll just add over here in like parentheses, info section to help remind me what's happening. And we probably don't want to do it like that. Let's do it like that. But there's no title. It'd be nice if I could pass in a title. So this is an addition to the JSX syntax. If I want to pass a property into my info section component as an argument, I do it like this. And you can have it be in curly brackets, and you can have it be a string. We can put in a JavaScript variable, which we'll see in a little bit. But for now, we're going to put in a string. And what happens is that prop name is added as a property on this object. And we can console log it here. And we can see here it's a JavaScript object, title components. If we go here to the components tree, we see an error that we'll worry about later. And this property name comes from what we do here. If I change this from title to foo, then the property is now foo. So I need to know the prop names. Now, the pattern in React is to destructure this object because it makes life easier and it lets us be more explicit. And so this is normally what you will see. And this is where we can start to do more interesting stuff because we can pass in lots of different values. Like, for instance, maybe I want to pass in this component info list. And let me change this back to title. And why don't we call this like an info list prop, and we'll pass in the component info list. Now there's nothing in here, so it's not that exciting, but there could be, right? Reusable piece of user interface. And then if I was doing something with this data, it could start to get really interesting. And we can see here our console log print statements from the info section. And if I go to the components tree, I'm not sure what's throwing the error right now. It can be a little finicky. But now we can start to get somewhere interesting, right? Because maybe I want to be able to, instead of having this all live here as list items, maybe I want this to be data in an array. Maybe I want to grab this and over here, put this stuff here. And forgive me as I kind of do some hacky transformation here. And we'll just do 3 of these things in the interest of time. And now I've got a list of information. And it would be really nice if rather than having all of this be hard coded, and let's just in fact comment all this out so the notes are there if we want to look at them later. If instead we could, maybe map through that array and display it. And the good news is we can. And I'm just going to call this item. And we're going to make a list item. When you generate a list of stuff from an array, or whether it's a list item or a div or anything else, we need to use a special property called a key to help React keep track of things. And let me look at my guide code real quick to make sure I get this right. But I believe it would be something like this. Let's see, item, and then index. And we're going to add a property here called key, and we're going to set that to the index value. And inside here, we're going to render the item, which is our message, and we're going to close out the list element. And lo and behold, I got lucky. The gods favored me. And it worked. And we can see that now as a prop passed into our info section is this array, but we take this array and we map through it. And yeah, we're not going to worry about that. And we're not going to worry about that. And we generate a list item for each item in the list. And now this is generated. And this is great because now I can use this component for props as well. And let me just pause here and see if folks have any questions because I've been talking for a minute and I just want to check in and see what people are curious about and what's on people's minds. How are we feeling about this? Pretty good. Anything in particular we want to take a look at here?
Can you show us what the error would look like if we didn't put the key in there? I just want to see, like, for future reference, that way I know what to look for.
Yeah, that's a good call. I don't think it breaks, but you do see this warning. Each child in a list should have a unique key prop. And as your React app gets bigger, it can get a little screwy if you don't do it. So it's better just to do it. It doesn't even want me to use the index attribute. Remember, we talked about the virtual DOM, like sort of adding IDs to each element. I'm pretty sure this is related to that. Let's see here. There we go. And I think we'll just this is actually from our curriculum in the curriculum doc, so I'll get rid of this. And now we have a really nice info section. And these squigglies we can ignore because props validation is a little out of scope for today. But you can use tools to validate that you're passing in the correct props. Let's use this same info section for props as well as components. So we've got our components info list, and let's make a props info list. And what we're going to see in a minute is modifying how state and props interact. And I'm going to grab each of these, if you'll just bear with me for a minute. And I think I'm just going to grab 2 of them. A component re-renders when its props change. This is important, and we're going to see this in just a couple minutes. So now we can add another info section whose title can be props. And when it's just a string, you can do it like that. And the info list prop is now props info list. Now it looks like I have something. Oh, I have something hard coded somewhere because I'm seeing components overview twice. So let's go here and see what we need to fix. And it would be this. Let's just get rid of that. And there we go. And now I have one info section component. We didn't really get to the subsection, but that's okay. You can kind of expand on that and see where we're going. And it's grabbing from 2 different lists of things, right? Now, what if I want to be able to like dynamically change this? This is where it can start to get interesting. Let's add an input field. Alex, yes, sir.
Is there a reason you don't have curly brackets around the props in the title there? And does that make a difference, really?
Yeah, great question. If the value is like a string, and I think maybe a Boolean, you don't need the curly brackets. If the value is a JavaScript variable, then you do need the curly brackets. And like you can just like with the curly brackets in the VS Code, you can run GS code in here. Well, as I said that, that's because I need to finish my button and I need to fix my input. So there we go. Now that's working, right? I would recommend just always using curly brackets to get started, just to keep things simple. So let's maybe, I want to add a component fact. That would be pretty cool. So I think I'm going to use what's called a controlled component pattern here. Let's call this input component, set input component, and the value here will be input component, and the on change will be set input component e target value, I think is the way to do it. Let's see if I got that right. What did we not like here? There we go. And so now if I put this in here, and in fact, if I go to component dev tools, I should be able to see in my app the state here for the input component is looking good. And so now I'm going to write an add component fact function. And what it's going to do is when it gets clicked, it's going to set component info list. And I think what I'm going to do is I'm going to make a brand new array and in it have the existing component info list. And to the end of it, add whatever the fact is here in this input field. And then I want to call this when I click the button. And my apologies, folks, I'm going to have to hop in just a minute, but this is kind of covering the key thing that I wanted to show here, which is, and let's look at the console logs and see what happens here. Components control re-rendering. Let's see what happens when I click this button. It shows up here inside the other component. And what we see here is that our component re-rendered. I think it looks like the props re-rendered as well. Components re-render if a prop changes. And let's clear this and see what happens. And it looks like the prop, I'm not sure why it's triggering the prop re-render here. It might just, I believe this might be re-rendering, but really it should specifically be this info section component here, right? As this changes. So this pattern is really common. We create state up high in a parent component, and then we pass it down into a child component. And you can do all sorts of interesting stuff with this. All sorts of interesting stuff. And I do apologize because we've hit noon, and so it is time for us to stop. And unfortunately, I do have to also go on another call. Otherwise, I would love to keep going for another 10 minutes or so. But I think this is a good stopping point because this is sort of the key piece of information here. We've talked about the React component lifecycle, how if state changes, a component re-renders. Well, if props change, a component also re-renders. And so by breaking our app into different components and passing state down as props, we can control what renders when and pass information around. Your assignment for today is going to build on yesterday. It's going to be, first off, these are going to focus on useState and useEffect. We're going to ask you to refactor what you did yesterday, learning today. And then this hangman is going to be a big one with components and props and state. And this is really going to be the one to focus on. So do these in order. And then the hangman one could take you a bit of time. Do folks have any questions around state or props before we wrap up? Okay, awesome, folks. Thank you very much. Again, I apologize. I have to wrap a little abruptly. I do also recommend if you look through this lesson on components, it walks through what we did just now, but it builds a task manager, which is, I think, a really useful scenario to see. So I would recommend just reading through this and looking over this code. And I'll have this code pushed up to demos and notes shortly. And I'll have the lesson video up within the hour.